All right, welcome everybody. Let's everybody give each other a hand because we're going to start this off happy. All right, we have a good day. All right, we are in day 2. I'm assuming this is day 1 of the expo being open. So my team is here with our team on the floor. We're going to talk about where you can find us there. But most importantly, this is day 2 for all of our attendees. So sessions are going great. Thank you for joining us for ours. First introductions. My name is Eric Wright. I'm the Technology Evangelist and Director of Technical Marketing at Turbinomic. You can find me at Disco Posse on Twitter and LinkedIn and everywhere else. I'm the easiest one to find because I have a strange moniker. I'd also like to welcome, of course, my presenters to join me today here. Moore, introduce yourself and tell us about yourself.
Hi, my name is Moore. I'm a Senior Product Manager, specifically for what we're doing around cloud that we will be talking around today for Turbinomic. And it's a pleasure to be here with you.
And also Charles.
Good afternoon, Charles Crouchman. So I'm the Chief Technology Officer at Turbinomic, responsible for product strategy and direction. And hopefully by the end of today's session, everybody will understand the way Turbinomic thinks about how to optimize both performance and efficiency in your cloud environment. So
safe bet. We got a couple of AWS users in here today, right? We're good, we're covered there. Most importantly, who's here has heard of Turbinomic so far? Alrighty, excellent. I ask a lot of questions. Who here likes to raise their hand to answer questions? Who here does not like to raise their hand to answer questions? Okay, just want to make sure we're all on the same page. First, we want to talk about why we're here. We've seen incredible growth. It's funny, I was just talking with some folks, a good friend here, Randy Schaup. My other star is in the room here. He's a great guy. We've talked about the growth of AWS as an ecosystem and as a show here. We're at 43,000 people joining us here this week, which is awesome. It was 34,000 last year, and instead in 2012, there were 4,000 people here. We could have had 10 of these rooms, and it would have filled with every single attendee in 10 rooms. And now we're across multiple hotels. Our company as well, watching incredible growth and seeing that adoption in our customer ecosystem. And we really wanted to talk about first, why? Right? The importance of it. It's kind of that whole, let's step back for a second and think of what it is that the public cloud gave us. You know, AWS opened the door to these very interesting things. Number one, being able to get stuff on demand. I'm assuming a good number of folks who are from the operations side of the world, we've racked a few servers in our time, we've stacked a few servers, we've plugged in cables, we've gotten yelled at because we haven't done it fast enough. And that's really the core of how do you do this on-demand capability to be able to match the speed of business. And 5 years ago, and further back, it wasn't really, the business moved at a speed that kind of lined up with racking servers. It's not the case anymore, especially now that we have multiple options for being able to get on-demand services. So you think about the broad ecosystem AWS has. And of course, not just being able to get it on demand, but to grow it as you need. Because you don't know necessarily what you're going to need today, tomorrow, next week, and as your organization grows. And I hope that all of you are growing elastically in your organization so that you're getting the advantage of this stuff. So being able to scale that infrastructure and then give it back when you don't necessarily need it anymore. And also being able to spread your wings. Getting geographic diversity, so that means that you have protection. We used to have a single data center go down, could wipe the whole company out, right? It's a huge regulatory issue. So we had to have secondary data centers, twice as many servers, sitting cold over here. Right now we've changed the game because now we have the ability to have geodiversity for all of your application infrastructure. And you can spread it easily, using their own back end. Some really cool offerings and advantages. And then beyond just the traditional rack stack server, that full stack, being able to go further up the stack and adjacent services. Like we talked about Elemental that just got launched. And we've got all these neat things around VR and all these new services. And at 8 o'clock tonight, you're going to hear Andy Jassy talk about a whole huge launch of a bunch of other services. I don't know any more than you do, but I know there's going to be big announcements, right? So we're seeing these huge options about being able to leverage other services in that same ecosystem that we couldn't stand up ourselves in any reasonable amount of time. So this was the goal, right? Accelerating your business. So you've learned as a company to be able to leverage services and resources as you need them and trying to figure out what's the right way to consume that. And you've also moved to this new operational model. I'd say 4 years ago, we used to talk about how the cloud's expensive. And that was an easy detractor from it because it seemed like it was relative, because we already owned all this gear. So it was tough to justify spending more money. So now we have this new cost model. I always used to say the cloud is cheaper if you're willing to pay more. But what we've learned is now we can adapt our cost model to map to it. And now, again, you've got fluctuating requirements. So being able to change the services you consume and being able to use this infrastructure now to line up with the demands that you have. And then, again, enabling these new design patterns, because you don't have to stand up one server. I came from the old school of, like, one application meant one server. In fact, it wasn't just one, it was 4. You needed to have a cold backup just in case. If it was hot, you needed to have a second server just in case, and it was clustered. Then you had a third cold one over there. Then you had a disaster recovery instance sitting somewhere else. Then you have offsite backups, right? So this is the change in the design patterns that we can scale out and up as needed. So what are the goals of every organization? Everybody has all these different needs, whether you're in financial, medical, whether you're a company that's collecting papers and sharing them out through your community. Whatever it is, you're using IT in some method. And so when you think about the applications you run, you have to be able to assure workload performance. And that's the true end-to-end customer experience, whether your customers are your own internal staff or whether it's external-facing websites and web-based applications. So you need to be able to make sure that you can deliver that high quality to keep customers, because you're not the only ones who figured out that this Elastic thing is cool, so you've got competitors in the space now. And then we have now this challenge of making sure we do so in the best cost. And Charles, you know, what does cost mean when we talk about this in this way?
Right. Well, I mean, one of the primary reasons that we go to the cloud is elasticity. It's got this effectively infinite pool of resources available to you that can be provisioned dynamically on demand, right? So as a result, because billing is based on allocation, not on consumption, your costs can get out of hand in an elastic way as well. So you really have to pay attention to, as I'm dynamically provisioning resources, how do I control for cost? Now, what you really have to do, though, is not just control for cost. It's not about cutting your bill. It's not about reducing your bill. That's a noble goal, but the real thing that you need to do is figure out how many resources does my application need in order to perform according to my service level agreements, and what's the lowest cost that I can achieve within that constraint. So it's never about just taking away resources to reduce costs. It's about not having to over-provision to assure performance. It's about making sure that I'm spending the right amount to get the performance I need. Never just about cutting costs.
You can say, who's over-provisioned in their data center today? Raise your hands. All right, all those people who didn't raise their hands, seriously, raise your hands. Come on, we as a practice over-provision because we own the gear. That becomes critical when we move to the cloud. Not only that, who's in a regulatory-bound industry? Whatever it is, you could have different things around data locality and such. More, you've been in a lot of spots and you've seen this. What are some of the compliance challenges that we face when we adopt public cloud?
I'd say the two major ones are around data sovereignty and high availability. Around data sovereignty and GDPR, making sure that instances only run in places that they're allowed to run, data is accessed and placed only in places regulatory allowed for that data to reside in. But then around high availability and geographic redundancy, making sure that also instances are spread across as many availability zones as possible to both comply with cloud SLA contracts, to be able to deliver on 5 nines of availability, and then more than that, to make sure that you have if a zone crashes or a region crashes, you still have data continuity, business continuity, that you lose your services because of that.
When I was on the way out in the lineup at the airport, someone asked me, they said, "Oh, you're going to Vegas for reInvent?" Because they saw a sticker on my bag. And I said, yes. And they said, "Do you gamble as well?" I said, yes, I'm running my website on one EC2 instance in US East 1. So when we talk about that, we've accepted there's challenges there, right? And interesting ways that we can leverage this new ecosystem to get away from being caught out with stuff like that. But again, firing up dozens of instances introduces other challenges, and we've learned to try to figure out how to find this equilibrium. And at the same time, why do we do all this stuff? Because we want to be digitally transforming, or we want to be agile, or DevOpsy, or whatever the thing is. We ultimately are trying to be more aggressive in the way that we can innovate. And Charles, again, you've come from a couple of different organizations and you see a lot of stuff day to day. What are driving people to do this digital transformation?
Well, so in the context of what we're talking about here's the conundrum. The conundrum is, as IT professionals, we're in the business of automating our business. And as IT professionals, we're one of the most unautomated functions within the company. So we've done a lot of work. You'll hear a lot of talk about automating provisioning, CI/CD via DevOps. What we don't automate well are the decisions that we take every day in configuring our infrastructure. We're really not good at that. What we like to do is get a whole bunch of data and then make manual decisions about what that data tells me on how to configure my environment. And that's absolutely the wrong way to do it. What you really need is you need to build a software system that automatically takes decisions on how to configure your environment based on continuous understanding of application demand and infrastructure supply. So the way that you get your team more effective and efficient is through automation. And automation does not just mean provisioning. Automation also means the continuous configuration of your environment to make sure your applications are getting all the resources they need at the best cost.
And the classic thing, what do we want? Cloud. When do we want it? Now, right? You've been told by your CIO, we got to go to the cloud. Maura, I know you've got more than enough stories on this one. Maybe share one.
So a good example from recent is we were working with a large organization that since the beginning of the year been planning a lot of migrations to AWS, and 6 months in had 400 workloads already running in AWS. And since they didn't really adopt the mentality of agility in cloud and how to operate using best practices, they realized that for 400 instances running in AWS, they were paying $4 million and halted all migration efforts to AWS until they figure that out. So accelerating is about understanding how to best utilize, how to really unlock true agility in the cloud to benefit from the elasticity that cloud provides, to be able to be agile and elastic, to then really be able to deliver on the goal to be 80% in the cloud by the end of 2018.
And I can say this is as we have 2 Canadians out of 3 on stage here, we can say that we put the A in AWS. I just wanted to, we know this because we've seen this in customer experiences and our community experiences. And I would bet that if I poll people in the room, we're going to hear similar stories, that we've had those deadlines given and we've kind of, what was it? Somebody said that I love deadlines, and that swooshing sound they make as they fly right by. So we come down to sort of tactical questions from all that stuff. That's great. You want to digitally transform. But what does that mean to the operations teams, right? We have these questions that we ask all the time, every day. What's the right CPU and memory combination for my workload? When I think about mapping to the cloud, when I think about what block storage matches the demand of my application. And these questions aren't just like a one-time, I need to know the answer to one of them. They are interdependent because you have to think about compute and storage together, network, placement, geodiversity, right? All of these things come into this plan. So when I think about geographic resiliency, I now have 3 dimensions that I'm looking at around compute, storage, and placement. And then on top of that, I want to leverage database services. How am I getting the ideal layout and performance capabilities and cost performance from that? And then which on-premises applications are the right ones that I should look towards the cloud for, right? Because we don't just erase, like an Etch-a-Sketch on our infrastructure and then start again in the cloud. We have to migrate some of this stuff. And we did this with P2Vs from physical to virtual. That was a terrible idea. But we did it because it was the first generation, and we learned, and then we started to adopt. We are going to do that today. We're doing it in cloud. So we're P2Ving. We're V2Cing now. We're virtualizing to cloud. And it's cool because we're going to make a couple of learnings and some mistakes, and then we're going to get through it. And all these questions and more, right? And this is not just a one-time thing. It's every day, every second, your infrastructure is moving around. So these are questions that need to keep getting asked. And then it ultimately comes down to a very careful set of trade-offs. Right? Number one, we want performance. We want our applications to perform well. So that's great. What do we do today? We throw capacity at it, except there's a problem. Capacity costs us by the hour, by the second, depending on what you're consuming. So you have to think of the trade-off between performance and cost. And then we have to be concerned about compliance, again, around diversity, disaster recovery, around GDPR and data locality and placements and such. And then adopting this new operational model. No one wants to say you failed at the cloud because you did it wrong. Like, the cloud's there to be gotten. Other people have succeeded ahead of us, but they probably made mistakes and forgot to tell us that part. We've all learned the hard way, and it's good that we can share that story. And then now being able to take this new operational model and scale it as you go. So going forward, we're not going to get pulled back into the same traps we had that led us to this point in our growth. And I'm assuming that based on a couple of folks that look like near to my age or perhaps a little younger, but you've seen physical to virtualization, right? We saw this thing happen. We've got containerization that's going on over here. We've got all these other things. So we've seen these patterns change along the way. And so now we have to think about, what does this mean every day tactically inside your data center, inside your cloud, inside your application? I talk about this as kind of 4 pillars of things that we look at from technology itself. And it's funny that it's almost elegant in its simplicity, that it's too easy. There's compute. Makes sense, right? Storage, got to keep that data somewhere. Network, we got to access those compute nodes and that data somewhere. And then ultimately at the top of the stack, the important part of it all, is application QoS. Like, we all came, I'm assuming a couple of VMware virtualization kids in the room. You've probably spent all this time tuning your underlying infrastructure to make like these super happy hosts. So like, why were we doing that? We did it because we wanted to be cool and solve host happiness. But the problem is we were not attacking the problem, which is really application happiness. And so application quality of service and true measurement of end-to-end experience is what's important. And this maps to not just the physical layer, but through virtualization, through containerization, and up to the app. And I'm more as a developer who's had to deal with mapping this stuff up. What do these things mean in the application layers?
So when you think about application performance and delivering SLA and quality of service, the first thing that matters is the application actually gets the resources they need in order to perform. It's like when you're running on your laptop too many applications at the same time. It doesn't matter what the application actually does, it won't perform, right? So it's about delivering the resources that the application need to be able to deliver on their SLA. And whether you're running that application on a container, whether you're running it on an IaaS instance, on an EC2 instance, or on a traditional VM, you need to make sure that wherever it is running, it gets the access to the resources that it needs. You have to look at it in the context of the SLA and within the application. You don't want to treat an application that garbage collects once a minute and an application that garbage collects 3 times a day in the same manner. So you need to understand the application, and then you need to understand the impact to the underlying resources and the underlying layers, whether it's PaaS, IaaS, VMs, or containers.
And effectively, every single one of those layers has CPU, storage, right? Like, that's common things that go throughout that stack, which is where it's fun. Now, AWS has a few options available. We call it, I kind of like the painter's matrix of things. If you've ever been to a Bear store or a Glidden store or whatever, and there's maybe Canadian companies. I'm going to pick American companies I can bet. Whatever a good American paint company is. Regardless, you go to that menu and you've got lots of options, right? Being able to understand different families, understanding size within those families. What does this mean for us? Tell me more.
So when you look at the different template families, there are multiple things that differentiate between them. The major one being the ratio between the different resources that you get, compute to memory to storage to network. And once you choose a certain family type, you're locked into that ratio, and as you move between the different sizes, you stick within that ratio and you add and remove resources across all those different dimensions. Also, there's the hardware underlying that instance family. So 2 cores on the M family and 2 cores on the R family won't necessarily deliver the same performance. So it's important to not only understand how much resources, how much cores and memory and network those instance types give you access to, but the actual underlying hardware performance that you can expect out of it, the benchmarked performance of those family types.
Right, and the point to make here really is this. In the simple act of choosing which instance type to run my application on, you're doing 6-dimensional math, if you're doing it right? You're not just saying, I need more CPU or I need more memory. You have to look at everything from CPU and memory allocations through to the implications on network and storage. And you have to understand the relationship between the compute instance and the underlying storage and the connected network. And you have to be able to consider all of these things simultaneously while understanding the application demand for resources to make the simple decision of what instance type should I choose. And as we look at the customers that we've engaged with, those who do it without the proper analytics, whether they're using immature software or whether they're using their own spreadsheets, choose the wrong instance type more often than they choose the right instance type. And what's the right definition of wrong? It's either over-provisioned, right? You're paying for more resources than you need, or it's under-provisioned, right? You don't have enough resources and your application is starving as a result and underperforming. Either one of those situations means you made the wrong decision. But to make the right decision, it's a simple decision, choosing the right instance type, you have to be able to do 6-dimensional math. How many folks in the room can do 6-dimensional analytics in their head, right?
Someone's got to be brave.
Not too many. So it seems like a simple choice, but it's actually a very, very complex choice just to choose the right instance type.
And you've picked your CPU family, and then that's great, but now you have storage to account for, right? We have a few different options. Even though there's less options, for us, we're in still a few dimensions there, right? Not only being able to understand family and style, but size as well. And what does this mean?
So you have 4 different current generation EBS tiers, and the performance that they actually give you is dependent on the tier that you choose, the amount of storage that you provision on each one of them, and again, in the context of the application. So it's important, and what we know from customers and from the AWS teams that we've been working with is that 80% of storage volumes in AWS are actually using the wrong storage tier to deliver application performance as efficiently as possible. Choosing the right tier is important both for performance and for efficiency because the cost difference is about 4 times between provisioned IOPS and SC1. Now, it's important to understand that by default, you get GP2 whenever you start an instance. So if you launch an instance and you click next, you're running on GP2, the second most expensive EBS tier. Do all of your applications really need flash storage? Probably not. So it's important to understand. Plus, moving between those different storage tiers has no downtime to the application, so you can do it in runtime, even for production workloads. But leveraging that is complicated, again, because of what Charles and Eric have been saying. It's in the context of application performance, and it constantly changes. You'll have applications that have I/O peaks once a month or once a week or once a year. If you make decision based on peak demand, you'll be over-provisioning for the rest of the year.
Right. So why do people choose the wrong storage tier, right? Why do they do this? Because they care more about performance than cost. So I'm just going to go to I'm just going to go right to the fast SSD, right? That's the number one reason. But then why do you not adjust it after you've made that decision, right? One is risk, because if I get it wrong and the application performance suffers, I lose my job, so I think I won't do that. Or alternatively, I just don't know. I don't know the answer to the simple question, what is the right tier, right? So you have to be able to understand historical demand for resource from the application, and you need the right analytics that knows how to look at historical peaks, averages, sustained volume to choose the right tier that gives you the best balance between performance and cost. You can go all the way to performance and over-provision, or all the way to cost and takes performance risk, but the only way to find the right balance between performance and cost is with the right analytics.
A lot of us use I call it the Ron Popeil Method, set it and forget it. We launch it once and you hope you were right. And as Charles mentioned, no one's willing to go back and say they were right. Who here knows how many IOPS their application consumes per application? Don't worry. We got one brave gentleman who's going to hire that fellow.
Right.
Randy, hire that kid.
And it's fantastic. It's fantastic that you have the data, but can you do 6-dimensional math in your head to figure out how to configure it?
There we go. Honesty as well. Definitely hire that kid. We think about this challenge that we've got, and now let's go further into other adjacent ecosystem. We look at the database services, and I'm assuming folks have gone from launching databases inside EC2, and you've got leveraged RDS. You know, database as a service was wicked cool because now you can have the ability to scale it as needed. But again, making decisions around how do I think about what are the right reasons to deploy and scale that on day one and beyond. And more, I know, having worked in this and building our platform to be able to deal with this stuff, you know why these are challenging.
Right, so when we talked about the instance types and EC2s, everything is very similar in RDS. When you choose a family type in RDS, you're choosing the compute, memory, I/O, and network that instance gets access to. But you need to keep this in the context of how much memory that database is actually consuming. And as we all know, it's sometimes harder to get that data than we think. We can't just look at the IaaS layer or the PaaS layer. We need to look within the database to understand how it's consuming its resources to make the right decision. So it's about looking into the application. Sorry about that. Into the application layer, understanding how these databases are using their resources to then make the right decision on how many resources do they need to be allocated. Now, what the great thing about RDS is that it gives you scalability, it gives you agility, and it gives you elasticity. But to really unlock them, it's important to look at the consumption of resources in real time and adjust them and scale them according to the actual demand for resources. How much are you pinging that database at any point in time? And are you leveraging that change in demand patterns to unlock that elasticity that RDS provides?
And critically important, again, is the fact that all these choices are interrelated, right? Your choice of storage has implications on the right instance type to choose. The way you configure your database has implications on the instance type that you choose and how you configure your network. So not only is it hard to make each of those decisions individually, it's even harder to make them in the context of each other, right? So now we're up to, I think, 18-dimensional math in your head.
It's getting exciting. I feel like I need a mathematician around me all the time. All right, you've hung on with us so far. Now here's the big reveal. This is the prestige, this is the turn, right? We really want to talk about what Turbonomic has done to solve these challenges that we face. This elasticity that we gained introduced new challenges and multi-dimensional math into the environment. And I think, obviously, as the CTO, I think he can tell the story the best.
All right, so how do you figure out, so what we've really spoken about so far is we're setting up the premise, right? What is it, what are the problems around resource management, around configuration of the infrastructure in AWS? What are the problems, answers that you have to, the questions that you have to answer in order to best configure the infrastructure in AWS to get all the performance I need without spending more than I need to, right? That's fundamentally what it comes down to. So how do you solve that problem? I can tell you how we've chosen to solve it. So it all starts with the data model. Well, actually, it all depends on the analytics, but you can't do analytics without the right data model. So you have to fundamentally get the data model right out of the gate as you look at all of the services that are available, all of the resource-based metrics that are available for these services. You have to understand that, and you have to understand how they all interrelate. Because if you don't understand the relationships between the resources flowing through your applications in the cloud, you can't make decisions about how to configure them, right? Because if I choose memory without understanding heap, I'm going to be wrong. If I choose an instance type without understanding the storage it's connected to, I'm going to be wrong. I have to understand how everything's connected, and that's the data model. That's the starting point. The second thing you need is you have to have the right analytics over top. It's really easy to say within an instance family that I need to move up to the next larger instance size because I'm peaking on CPU. That's not analytics, right? Analytics is looking across everything that I've got, understanding the relationships, and making all of these decisions in the context of each other. Analytics is understanding application demand for resources, sometimes by looking inside the application, sometimes at the IaaS layer, sometimes at the PaaS layer, understanding all of the infrastructure supply of resources, and then having a very, very deep, multi-dimensional analytics engine in the middle that knows how to make decisions on how to configure the cloud to give you all the performance you need without overpaying on cost. The analytics matter, right? Simple recommendations around which instance type to choose. If you don't have the right analytics that considers everything in context, not only will you be suboptimal, you can actually hurt yourself. You can constrain the performance of your application. So be very, very careful in looking at the analytics that drive your decisions around how to configure cloud infrastructure. It's very important. The third is automation, right? So data is great, right? At least you've got visibility. Data plus analytics is better. Now I've got decisions. I've got actual recommendations around what to do in my environment to make it better. What's even better than decisions is automation, right? Now I can actually automate those decisions and have my cloud infrastructure capacity self-managing, right? Because as soon as you put a person in the middle of this chain, it either gets too slow to react to changes in demand, or you just don't do it. It doesn't happen. Data is good, decisions are better, automation is best. But the only way you can turn on automation around managing cloud capacity is if you can trust the decisions made in the software, which also always comes back to the quality of the decisions from the analytics. Frictionless says if this thing is hard to deploy, if I have to deploy a massive network of agents to be able to get the data that I need to make these decisions, that becomes a management burden. Whenever there's a platform transition, and I've seen them all, going back from mainframe to Unix, we relearn all of them from all of the mistakes that we made in previous platform transitions, right? When we moved from centralized computing to distributed computing, we learned that large networks of distributed agents became management nightmares. So we all started to use APIs instead of agents. Don't go back to the days of deploying large networks of agents. Look for solutions that rely on standard APIs. And then finally, real-time matters. What you've heard us talk about a lot is understanding application demand. Application demand for resources is not static. It changes over time. How useful would autoscale be if it only woke up once a day and checked whether you needed more instances? Not very useful, right? So the same thing is true of configuration changes, specifically related to resource capacity. You need a real-time engine that is continuously assessing both supply and demand and continuously producing recommendations that can be automated. Right? Otherwise, you can hurt yourself. So, data model that understands relationships, deep analytics that considers everything, is able to do multidimensional analytics continuously, take the decisions from those analytics and automate them. Make sure that you're deploying in a frictionless way with APIs, not agents. And make sure that what you're looking at is continuous and real time, not periodic defrag. Does that make sense?
And what we strive for in doing this is truly being a differentiated platform, because we can do all this together and drive towards being truly self-managing. Ultimately, it should be autonomous as much as possible, or at least be able to get to that destination of autonomous. So Autonomic gives us that capability to automate at your comfort level and go further. And we've got a variety of customers who can talk about their different depths of adoption and how much they've chosen to completely create self-managing infrastructure. Being comprehensive means being able to truly go from the applications through virtualization, through cloud, down to the physical layer of the stack, and be truly multidimensional simultaneously. So understanding all of those actions are driven in not just to affect that particular entity or that instance, but everything around it. So if I were to say that I've got a couple of spots here, so I've got 3 seats, I only think about those 3 seats. I don't think about there's 5 seats in a different row that are empty. So if I fill these 3 seats, I'm going to make those poor 5 people around them uncomfortable because I've loaded them up. Why don't I move those people in different places, right? Everything has a secondary action. And beyond secondary when we talk about this 16 plus dimensional mathematics we got to do. And being able to be hybrid. So we've been succeeding on premises in environments since 2009, 1,800 plus customers, which is pretty cool, pretty proud of that. And more so, that we've watched our customers go through this journey towards cloud and hybrid cloud. And not hybrid cloud in the way it was 4 years ago, which was like, we all had this dream, I'm gonna take an application, it's gonna burst to the cloud. Anyone doing that? No, right? It was a cool concept, an intellectual concept, but we realized that it was far away from the data. We didn't have the orchestration layers to be able to solve that problem. So truly hybrid means using the cloud as an additional part of your IT portfolio and being able to leverage the best of breed of each of those capabilities. You got sunk cost infrastructure, use it as best you can. Treat the applications like kings at every layer. And again, being able to be a true full stack unified platform. So I'm not going to tell you I'm a single pane of glass because I know you got 11 single panes of glass in your environment. You've been sold that story more than once, but I can tell you that being a unified platform that touches every part of this in one place, that's where the value comes. So I think about self-managing platform, again, being able to automate these decisions. You can't be self-managing if you're just simply giving a list of recommendations to your team. You got a smart bunch of people working for you. They shouldn't be sitting there answering questions from software, making decisions. The decisions have been made and they're automatable. Being able to optimize both your on-prem and your public cloud infrastructure for both utilization and cost, making sure, again, it's this trade-off of finding the equilibrium between performance, cost, and also maintaining your business rules around compliance. And then being real-time, continuous control across the entire hybrid environment, and also understanding costs, because we have this idea of virtual cost because you have sunk, fixed cost infrastructure. But when you go to the cloud, these cost decisions are real-time, by the second, by the hour charges that you're going to see. So making sure that when you're optimizing, it's being done at all of those layers. And this means that for us, I say it's high T visibility, and it almost detracts from the story a bit, because it's not just being able to see it, it's being able to control it. And that's where we look as why Turbonomic has taken the tact we have of understanding that all of these things come together.
So really at the core of what we do, for us to be able to do everything that we've talked about and everything that Charles explained that our platform can do, to do this 16-dimensional analytics, we need to understand the environment. For our actions to be automatable, application performance is the topmost concern. So we have to understand everything from the application layer down to whatever infrastructure, IaaS, or PaaS services you're using. And that's our complete hybrid visibility across on-prem, all the way from the load balancers down to the infrastructure, storage, network, infrastructure, and in the cloud environment, again, all the way from elastic load balancers down to the different PaaS services, the different configuration options, the different billing capabilities that you have, the different models that you can use, all the different services, understanding those, and then building a model that incorporates how all of these different things affect each other, so that we know if you add more CPU to this instance, how that is going to affect response times of the application. If you deallocate half of the memory by moving within the family type one step down, how is that going to impact the transaction rates that your application can deliver? To do that, or for example, if you move one component of an application to the cloud, how does that affect the overall performance of the application? To really understand that, we need to have that full model of everything from the application layer down to the infrastructure. And that's at the core of what we do.
And how do we work with AWS? The great questions that we will answer today and beyond. Obviously we talked about compute, storage, and RDS. We're going to focus on those ones right now, and you can imagine that based on our growth, we can imagine that we're going to spread into many, many more areas within AWS. Today, we do some really, really cool stuff around EC2 and EBS, and Charles is going to walk us through what that means.
All right, so really what does this mean at the end of the day? How do I configure the infrastructure in the cloud to make sure my applications perform without overspending? So I have to choose the right instance type, meaning I need to scale my instances. And why does real-time matter in this case? So changing an instance type is a disruptive action. You have to take an application outage. So why does real-time matter? If all you're doing is trying to downsize your instance types to save a little bit of money, you can do that periodically. Even though there's per second billing now, you can do that periodically. But if you've got an application that's under-provisioned, where performance is constrained because you've underallocated resources to this application, you want to know that. You want to know that when it happens, right? And it may be worth taking an application outage to correct that. So you need real time to be able to deal with performance, not just efficiency. Deployment and migration planning. So for those of you who are running in hybrid situations where you've got existing on-prem applications that you're moving to the cloud, you want to be able to understand the implications of moving those things before you move them. So you want to be able to understand the applications you have on-premise, and you want to be able to translate those on-prem configurations to cloud configurations. Identifying and reclaimed unused compute and storage. So fundamentally, because of the billing model in the cloud, you pay for what you allocate, not what you use. If you're not using something, you should deallocate it, right? Non-disruptive storage migrations across tiers. So remember we talked about instance type changes being disruptive. Storage tier changes are non-disruptive. You can do them without an application outage. It's another reason for making sure that you've got real-time automation available. And then finally, complete cost and performance control and visibility. When you take all of this and put it together, what you're trying to do is making sure that you've got not just cost visibility, not just the ability to reduce costs, but the ability to make sure you're assuring the performance of your applications while controlling cost.
And we get into not just your current on-demands, but obviously anybody using reserved capacity trying to, right? Like this is a great advantage that we have available to us, and how do you make decisions correctly to best leverage that?
So can everyone hear me? Okay. So we're looking at it as in some ways separate, looking at our eyes as separate from optimizing the environment for performance and efficiency. But these things are all tied together. If you want to drive efficiency in your environment and size the workload down, for example, because it is over-provisioned, but it's currently using a reserved instance that no one else could leverage, it's not necessarily going to increase efficiency if you execute that action. It's important to look at the environment holistically, but you can't also just think about it from a VM's perspective, because maybe it's using an RI right now and you want to scale it down, but there's a different instance in the environment that could still leverage that RI better. You need to look at the entire environment to really understand how to optimize usage for RIs. And again, to do that, you need to do this 16 or now even more complicated analytics across the entire estate to really understand, yes, you have increase and decrease in demand, but for that core usage across all of those instances, some come up and down during the day, up during the day and down at night. Some of them run constantly but have different shifts and demand patterns. You need to understand what that core usage is to understand how to correctly purchase RIs to unlock that additional aspect that AWS provides us to improve the cost and the TCO of that cloud environment. So you need to look at the entire environment holistically, understand how it affects scaling actions, and then how that ultimately affects the performance of the application, because as Charles said, performance is the key. So if you need more resources, whether you're currently utilizing an RI or not, you still want to size this workload up to make sure that you deliver application performance, which is the most important thing. So it's about looking at all of these different things together. Just adds complexity to that problem that we look at.
If you're making RI decisions without the context of understanding how you should be resizing your instances, or if you're making decisions on how to resize your instances without understanding your RI capacity, you're probably wrong. You're probably way wrong. These things have to be in the context of each other.
And one of the large organizations we've been working with, one of the things that they do to optimize their environment is purchase RIs. And we talk to them about the process that they go through. It's enormous amounts of spreadsheets over months trying to look at multiple data points to come up with an estimate that they know could be better. So it's about reducing that effort as well.
Yep.
If you think it's funny that AWS, they love saving you money as customers. Isn't that a bizarre thing? Like the traditional hardware vendors are like, no, sell them more servers, right? No, AWS wants you to have a good experience. And that's why they've been great working with us in making sure that we can deliver this together. And not just at compute layers and storage layers, but also the same story around RDS, the same capabilities being brought down into relational database as a service.
So yeah, as we talked about, automating real-time, looking at all the dimensions to find the right RDS instance for the right workload at the right time, and then being able to automate this to unlock that scalability that for most of our customers is why they started using RDS in the first place.
And then, again, what do we put where? I'm assuming that you're not all greenfielding in the cloud and dumping your old data centers. We have to think about what can we do with what we've got today and being able to use this engine to be able to drive these decisions and make the right decisions. This is key to this.
Right, thanks. And by the way, I promise you we're minutes from the demo. So here's the mistake most people make in cloud migrations. Right? As we know, there are a number of ways to do this. You can effectively rewrite your applications and get rid of the legacy applications. You can refactor them or you can lift and shift them. There are many models. But the big mistake that people make in a lift and shift migration in particular is they take something that was over-provisioned on-premise and then double over-provision it in the cloud. And whereas on-premise, if you oversize a VM, the hypervisor does a reasonably good job of hiding that sin by sharing resources at the infrastructure layer. When you over-provision an instance type in the cloud, it goes directly to your pocketbook, right? So you have to make sure as part of that migration that you're doing it based on resource demand, utilization, not allocation. If you go from allocation on-prem to allocation in the cloud, that's where the 2 to 3x cost increase comes from, right? What we're seeing across the industry is that when people lift and shift an application to the cloud, it results in something like a 2 to 3x increase in the cost on a dollar-for-dollar basis. And that's because they took something that was over-provisioned and double over-provisioned it. So you have to make that decision based on actual resource allocation, resource utilization. And understanding application resource demand in an on-prem data center is even harder than in the cloud because of the complexity and diversity of all the things that you've accumulated over the last 30 years in your on-premise data center. It's a really hard problem to solve. We spent a lot of money and time solving that problem. So the cloud migration is also a very difficult problem to solve and one that's very valuable. Eliminate that 2 to 3x bill shock as part of the migration.
And we also think about not just the on-prem to cloud, but being able to think of cloud to cloud as well. Like, what if I were to go region to region? Because there's differences across there. So we give that same capability to shop amongst the cloud. Or again, taking other cloud platforms and bringing them over to AWS. So being able to take those active workloads and do that. So that's using the right analytics that gave you that capability is a powerful part of our story. And we want to turn you from zero to cloud hero, right? We want to send you back to the office and make you think like, I've got a solution. Because this is really what we have as a goal. We want to make sure that we do these things right. We don't want to revisit it. You know, we've got all these things we talked about. I've got 18 months to go to the cloud. And then 24 months later, all right, we need another 18 months. You know, we've made those mistakes before. Being able to make sure that you not just size and scale that infrastructure in the cloud at initial launch, set it and forget it, right? Not true. It's dynamic. It changes. I worked at a financial services organization. We had a monthly process where we load PDF statements so everybody could get their account portfolio. And everybody said, like, on the 3rd of the month is when the statements come out. And we sent an email blast, your statement is ready. So we had all hands on deck. Everyone goes on call. We load up all the infrastructure. We free up all the stuff for the 3rd of the month. And then we went through the Google Analytics and figured out that on the 29th and the 30th of the month was the busiest days because no one cares about the PDF. The market's already changed. The real-time environment was the one that mattered to them. They were going in at the end of the month before they start because we had a real-time portfolio. So they didn't care about the PDF that told them about what already occurred. That was where real-time comes into value, and we see this all the time. Being able to get that visibility continuously and making sure that the decisions that you have, again, as Charles talked about, are trustworthy and you see the full context in around performance, cost, utilization, and finding that right balance in that approach. And then being able to truly be full stack. So literally application quality of service metrics. So understanding transactions, throughput at the application tier, down through virtual cloud and physical infrastructure. And then being able to be fully automated, self-managing. That's where the power comes in. Because it's all well and good if you can do these things. If you walk out on the expo floor, there's dozens of folks that'll tell you they can give you really cool reports and telling you some neat things to do. Then you say, perfect. So how do we do them? They said, read the report and hand it to your staff, right? Automate that. Do it with the same platform. And it makes sense for us to actually show you, because you're going to say, this is great, Eric, Charles, Moore, you've told me all these great things. Show me the money. We're going to switch over. We're going to show you what it looks like in the Turbinado platform.
Awesome. So this is the Turbinado platform, what you're seeing, and what you see here on the left is that model that we talked about, what gives you hybrid visibility across an entire hybrid cloud estate, all the way from the load balancers down to the infrastructure, down to the PaaS services, the types of storage, so you can immediately understand these are the load balances that I have, these impact these applications. These are the application servers that I have in my environment. I'm running on these database servers. And some could be on RDS, some could be in the on-prem environment. I'll try to zoom in here so we can get a better view of this. What applications do I have, virtual machines, and then how do they impact the underlying environment, both on-prem and in the cloud? So this could be, these storages are storages that you have in your on-prem environment across the entire hybrid cloud estate, together with the different EBS tiers, different tiers of storage that you're using within your cloud environment. Be inclusive for that entire hybrid estate. And then understanding the connectivity and the interconnectivity between the different application components, what database server is for what application server is connected, running on top of what EC2 instance, virtual machine in the on-prem environment, and then how all of these affect each other. Again, to understand at the application layer, how does application quality of service get impacted by any changes, right? So you might be looking at response time at the front end, but changes to the database that it's communicating, even if those are different components, would impact that decision. So understanding the connectivity between all the entities is part of that. And that just is a high-level view of everything that you see. Because we have that understanding of how those things interact, the consumption of resources within each of those layers, we can understand where you're over versus under provisioned, where you have performance risks in your environment, and where you can actually scale down and scale up, and then what would be the outcome to the business based on that. So you get an overview of everything that you should do to bring that model that we showed you to a fully green state where application performance is assured as efficiently as possible. And then the outcome to the business, both for the on-premise state, but more importantly, the cloud bill. In this case, saving over $1K in the monthly bill for that hybrid cloud estate. But as we said, in some cases where you'll need to scale up, you'll need to invest in order to add those resources. We're running a little bit close to time, but you can always visit our booth to get a more in-depth demo. I do want to focus on what we're doing for migration and look at that. So we talked about the understanding of that hybrid cloud estate. That in-depth model that we talked about allows us to help our customers understand what it is that they need as they do migrations. And in this case, sorry about that, if they keep the current allocation, where are they going to have performance issues? In this case, out of the 129 workloads we've migrated, 8 of them, if kept with their current configuration, are not going to deliver on their SLA, but 99 of those instances are over-provisioned, and these are the ratios that we see in the industry as well. If you keep that current configuration, what is it that you're going to end up paying for all of these workloads in the public cloud in AWS? And then if you fix that over-provisioning and under-provisioning, and again, across compute, storage, PaaS services, and so on, what is it that you would be able to pay? And then when it makes sense to choose RIs, what workloads make sense to purchase RIs for, and how much you can save by leveraging that aspect as well. So at a high level, now these analytics take about between 3 to 5 minutes to run and complete. So you can run multiple scenarios on different components to really enable you to make the right decision for your organization. And then as you decide that, yes, this is what I want to do, I'm ready, get the details of exactly what it is that you want to run where. Let's take a look at this application, for example. One of the VMs to be migrated, if you keep the current allocation, an M4 large is the best fit, which would cost $72 a month. But then if you fix that and actually improve the efficiency across that, a C5 large is the appropriate template for that workload, which costs $62 a month. And then that last column is if it makes sense to purchase RIs for that workload, how much would it cost if you purchase an array for that workload. But again, understanding where the elasticity and scaling up and down in real time makes more sense versus where you have a static demand for resources, and it makes more sense to pre-purchase that capacity long term. But then again, not only at the compute layer, but also at the storage layer. So for each disk associated with each VM in that migrated group of workloads, what is the right storage tier for that workload? How much do you need to provision on that storage tier, and how much that would cost you? So you not only get that top-level analysis to help you make the decisions, but also the exact details that you need in order to execute this. And it's all exportable so that you can feed that in to orchestrating platforms that would then execute those actions as well to make that as seamless as possible. So again, in this environment, what we see is usage of GP2, standard storage, and IO1, right? Not everything should be running on GP2, but understanding the difference in what makes sense to run on what RIs needs to be purchased, and what are the right instance types for each workload.
And all this stuff can be run repeatedly. It's a real-time call, as Maura mentioned. That's why it takes a couple of minutes to run a plan, because literally you're going over the entire workload profile of any workload or any entity within your environment and doing that real-time call out to the API to check for current pricing. So guess what? AWS changed their prices on Friday because they're good folks like that. Guess what? You make that same report, you rerun it again on Saturday, you get new pricing. Right? This is not a product update you're going to need from us. This is real-time API calls, and it's important that everything can be done. So it's as you look at planful changes, and it's also, inter-data center, cluster to cluster, data center to data center, cloud to cloud. That same capability on both real-time, day-to-day operational plus planning capabilities.
And what allows us to do that is that we have that model of your environment constantly maintained. So we already understand the environment, both on-prem and cloud, to be able to run those. We don't need to relook at all the data every time you want to run a set of analytic or a migration plan on top of that.
Right.
We already have that understanding and the model in place.
Right, and there's no time to show you, but there's a full policy engine behind this. Because to make these decisions, the software has to understand your constraints. You may have data locality constraints so that you don't want to consider every region available, right? So you could say consider all regions and we'll give you the best cost, the region that gives you the best options, or you can constrain those decisions. So there's a full policy engine behind this analytics engine as well.
And the cool thing is, if you go down to your seat, this is where the people on the camera hate when I do this because I move out of the camera line. Don't worry, there we are. There's a handy-dandy card here which gives you the chance to win something cool. If you come by our booth, we're at 2621. We're pretty easy to see. We're right in the midst of it all as you walk in through. You can come see. We can give a full-fledged demo, really cover the stuff you want. It's tough with such a large audience. We want to make sure that we cover the bases. We definitely want to thank you for taking the time today, because I know you've got to get on to lots of other things. Come by the booth. Also, if you grab one of our shirts, we've got a really cool shirt called Cloud Economist. You take a picture of said shirt, take a selfie, fire that sucker onto Twitter. Any Twitter users here? All right. Any Twitter employees here? You guys should be running us. What you do is you take a picture of that, you put it on there, and you get a chance to win. I think it's like an Oculus Rift and a bunch of stuff. So every day, and you don't need to come to the booth and hang out and wait for the show. You literally just take a picture of yourself, fire it on a Twitter with hashtag TurboShirt, and you get a chance. Every day we'll just email you and let you know whether you won. So with that, Maura, Charles, and with myself, thank you very much for taking the time.
Thank you.